This video is connected to the November 13th remote session, and we're following directly off of the previous video in which we were talking about kernel density. So remember, kernel density is a raster-based tool where you show concentration or intensity of a thing. It's how you create heat maps. What comes back to you is the expected intensity um, per square mile, per acre, per sort of whatever unit that you're identifying. And we sort of looked how, depending on this, seemingly simple, insignificant field here, search radius, you really change the geography at which you're identifying the concentration patterns, right? The larger the search radius, here we set 2,000 feet, every point spreads their influence, their heat, their intensity out to a farther degree. And so the overall intensity looks smaller, and you are kind of identifying clusters at a much bigger 10, 15, 20 plus block radius, right? That's where you can see that, relative to the rest of the city, when you factor in all crimes like theft and such, this part of Center City is definitely the most intense, right? Then you have obviously around sort of the university, then some pockets down here in South Philadelphia, up here in Kensington, and then sort of up here in North Philly. But that same analysis could be run with a much smaller, search radius, which doesn't tell a different story in the sense that you still have your Center City pockets and your pockets in Kensington and North Philly, but it really highlights sort of where those smaller sub areas are. Where in the University of Pennsylvania, where in Poplar, where down here in Center City, where down by the waterfront. And I wanted to sort of run that again with crash data. And the reason I want to do crash data is because crash data is sort of our first, incident where we can use a field to sort of help us, right? Each of these represents where an incident of a crash happened, but there's also fields here that let us know, like, was it a car involved? Was it a bus, right? There's an automobile. There were two vehicles involved in this one. And you could keep going over until you find a field, I think, that says bike. You may have passed it there, bicycle. Right, and in some instances there were no bicycles, but in some instances, if I sort maybe descending, I can see there were 2 or 3 or 4 or 5 or 6, or however many bicycles there. Where have my bicycles gone? However many there might be. And I can use that field, right, the bicycle count, to actually run this so that I'm only running the density for bicycles. In instances where there's a 0, it won't really contribute any value, and I'll only be looking at those places where there is an actual bicycle involved in the crash. And so I would load that into here, the crash data, and this is where the population field comes into play. I would be coming down and saying, let's pick bicycle count. Maybe I'll call this crash, and I'll pick a similar small one. We can go maybe smaller, 500 feet. So we're really looking very tight here. So the only things that are going to come back to you visually, right, at first, that are going to respond to your symbologies are going to be those areas where there's a high intensity of collisions and bike crashes within 500 feet of one another, right? So even though there may be some crashes happening over here in the Graduate Hospital neighborhood, you're not really going to see much intensity here because maybe there's a crash here and a crash there and a crash there, but possibly this section of Broad Street or an area of University City or this section of Girard where you saw a lot of bicycle collisions happen at the same intersection or same two intersections, that's what's going to jump out and appear intense, and that's the trend you're going to identify, right? Dangerous intersections. So this concept of search radius, can be a bit of an art beyond a science, and you do need to ask yourself that question before you run it. Where do I want to see and study concentration? If you're trying to visually represent concentration at a neighborhood or sort of multiple block area, 10 blocks, 15 blocks, use a higher search radius, 2,000 feet, 1,500 feet, whatever. If you really want to show like the dangerous streets for biking, or you really want to show like the very specific street corners where there's constantly litter being sprawled, right? If you had maybe a point data set of incidences of litter, Then you'd use a smaller search radius where you're really trying to hone in on those granular, more microscopic trends. So we'll keep everything else the same. Give that a run. And again, you're going to see something somewhat similar to that crime 750 we created, where most of the area, even if the density is small, right, and again, you'll see here when I sort of highlight that point at West Philadelphia, that there is just a lot of bike crashes that happened right at this sort of area right here, so that's why it's producing itself so high. But what I'll do is I'll maybe come to the appearance, I'll come to symbology, we'll pick stretch. I think a percent clip sort of will give us what we need here. So we'll come in and do that same sort of red level intensity, and then we can perfect. Then we can do a little bit of this. And now we can sort to see where the high intensity areas of crashes actually are, right? And so we can start to see these areas here, even if the density might be small, an imperceptible one here. Actually, it is 0 there, but I'm trying to get maybe a little closer. So like right here. Right, the density here, 74 or so per sort of square mile. If you take like the 1 or 2 you found and extrapolate it, you'd get that value. Versus here, where there are a ton of crashes, you feel like 600 or so, because there are so many concentrated in that small area. And that's also how you get that interesting value we saw over here in West Philly, right? If I actually click and try to get that point, and I come to the bicycle count, right, I'll see that in that area, no, it must have been, there must be a bunch of points on top of each other. So actually, let me come in here and do the select tool and just select this sort of high intensity concentration area. 27, right? 27 separate incidences where bikes crashed in that area of University City, or 27 separate sort of crash areas. Some of them are with 1, some of them sort of with 2 in terms of bicycle crashes. So a very high concentration at an individual block, and that is why it represents itself as seeing such a high number or such a high gradient of intensity surrounding only one point here. The last thing I want to make clear with density is, even though you can't run density on this is like a block population, population by block, and maybe I want to do this to show where there's high concentrations of people in general, or sort of maybe even age group. Let's see, I got a T here. There we go. So I have a thing here that shows me, 22 to 24-year-olds. So maybe I'll try to see where are all those 22 to 24-year-olds hanging out in Philadelphia are concentrated, or where are sort of the 10 to 14-year-olds, or even better, where are the under 5, right? Where are sort of the small children concentrated in sort of Philadelphia might be worth doing here. And that's stored in an actual field. So I can use that in the population field. And I could do it with any number of other sort of demographic indicators. That's just sort of the one that popped up to me. But I can't do it yet because this is still a polygon. Kernel density or any density won't take a polygon as an input. But if you remember back to a few weeks ago when we were first dipping our toe into vector-based analytics, in the data management features toolbar, there is something called feature to point. And all this does is if I drag in the blocks, for example, just let it have its regular output and hit OK, all of the attributes are going to retain, but what will change is instead of visually seeing this as the actual polygonal boundaries of the blocks, a centroid, right, the center of gravity, will depict itself now as a point. And remember, what's the purpose of a point? The purpose of a point is simply to say something happened here. But each of those points will then tell you all the information you had in the polygon, right? And so I can use that. I can now take that and load that into the kernel density. And that's sort of what we'll do to end this lesson here, just so that you are aware and can practice how having a polygon doesn't preclude you from running density. You just have to do that extra step to get the data out of a polygon and represent it as a centroid. So I'd say here, take the block features, I'm going to find that field I had. Again, I think it was sort of T, total population under 5. You know, with the total population under 5 in Philly. Where are they? Where are the young children concentrated? You know, I'll say, pop und 5. Get my cell size at 25. And, I'm interested not here. I don't really care. I don't want to see like the block. I don't want to see the blocks where there's a lot of, under 5 residents. I more want to see this at like a neighborhood level. I want to see like across multiple blocks. So, maybe I'll expand that search area to like 1,500 or so feet. So I'm almost looking at like the radius of a quarter mile or so. Square miles, keep it at density, run it. And then again, it's going to be looking in that field. So anywhere where there don't happen to be any children, under the age of 5, you're not going to see it. But anywhere that there are, it'll come back in tents. And we can change the symbology as much as we want, but maybe we'll sort of start with this. And we can start to see sort of the areas and the pockets of the city where you do have a lot of children, right? Or sort of concentrated. So interestingly, a ton in my neighborhood in a little south where we live, right? There are large sort of pockets and high concentration of under 5. And it certainly minimizes as you come into the downtown area, right? Almost non-existent when we head over to where you guys will be in University of Pennsylvania, but certainly starts to pick up as you head into the residential neighborhoods and such. So again, a really cool visual and analytic tool that shows you not incidences of a thing by vector units. So you don't summarize it by neighborhood or by block, or by parcel, but you start to break down those vector barriers and see the intensity that crosses boundaries. You look at a cluster pattern that is not dependent on any sort of administrative or human-made boundary. And that is density.